Right. So in this next chapter, we're going to start with ways that we can display data. So we want to use some sort of graph in this chapter, so we can present the way in a data, so we can see very quickly what's happening. What's a typical value? What are the extremes? What's the high? What's the low? And we'll extend this a little bit further in the next chapter with how can we talk about the center and the spread. The first graph that we'll talk about is a stem plot or a stem and leaf plot. It's going to be used to display smaller numerical data sets. So if you've got a numerical data and you have a fairly small set, you could go to the stem plot. So in the stem plot, each data piece consists of a leaf, which is just the final digit. The leaf is just one digit long, and the stem would be all of the preceding digits before that leaf. The number 43, 3 would act as the leaf, and the digit before that, the 4, would act as your stem. And the number 457, just the 7 would be the leaf, and 45 would be in the stem. And you have a vertical line that is going to divide the stem and the leaf. For example, if we were to randomly sample classes around campus today and see how many students are present in that classroom, here's our data set. We've got 25 students in the first class, 29 students in the next class, then the next two classes have 41, and so on. Our corresponding stem plot is shown below. And so here's how it's working. So we're starting with our smallest number. With our numerical data, we want to go in order from smallest to largest. If I comb through my numbers, the smallest number here is 17. So I would have a 1 in the stem, and I would have a 7 in the leaf. And the next smallest number after 17 is the number 18, which is right here. So that's why you're seeing a stem of 1 and then leaves of 7 and 8 here. And those are the only numbers in the teens. And then we move to our numbers in the 20s. I've got a 25 here and then a 29 here. So hence the 25 and then the 29. The 2 acts as the stem for both of those. And then 5 and 9 in the leaves. And then we would move to our 30s. And again, we want to go in order from smallest to largest. So even though the first number in the 30s in the list is 38, then a 38, then a 32, our leaves in the 30s don't go 8, 8, 2, but notice they go 2, 2, 5. That's because the smallest number in the 30s in the data set is this 32 followed by this 32. So I've got 2 2s. Then I've got a 35 after that. Then my 38, and 38 on the end. And then 39. Those are all the numbers in the 30s. And there was a fourth 38 that I missed, but it's in the stem and leaf plot. And you can see I'm scratching through the data pieces to make sure that I get all of those numbers in. And then you can see in your 40 stem, you've got 3 1s and a 3 for your leaf. So here's 41, 41, 41, and then 43. You have a 5 in your stem, but there are no numbers in the 50s, so we leave that blank, denoting that we didn't have any numbers in the 50s. And you can see it ends with a 4 and a 5 with your 6 in the stem. So there's your 64 and your 65. So we can now quickly see that typically a classroom has, 30-something students, 32, 35, 38, 39. But we can see classes as small as 17 or 18 and as large as 64 or 65. So we're able to quickly see, what's typical, what are those extreme values from our display. And if we move down to example 1, suppose that the data that we just looked at were for a sample of classes during the spring semester. If we take another random sample of classes during the summer, here is our data below. We want to make a stem plot for that. So we've got 32, 21, 31, so on to this 27 and 39. And so we could totally make a stem plot here for this. We could have a stem for our 1, and then 2, and then 3, 4, and I don't see any numbers above 4 there. We could do the stem and leaf plot here. I'm going to go back up to the stem plot that we just looked at and make a back-to-back stem and leaf plot. So I'm going to recycle the stem up here and just add in my leaf. So if I look, the smallest number that I'm seeing in my data set is a 14 right here. So I'll put a 4 next to that stem of 1, and there's also an 18 in the teens. So it's like we're kind of going in reverse we've got this 14 and this 18. The smaller numbers are always closest to the stem. The larger numbers are farther away from the stem. That appears to be all the numbers in the teens. So next I move to the 20s. I do have a 20 here, so I'll go a 0 next to the 2. I see a 21 here and another 21 here, so I'll put a 1 and a 1. And if we keep looking for numbers in the 20s, I see a 24 and two 25s. So here's my 4 and my 2 5s, and also a 27. Then I'll move to my 30s. I've got a 31 and a 32. I've got a 35, a 36, and a 39. And then that just leaves numbers in the 40s, 2 41s, and a 42 here, and here. And I've scratched through all my numbers, so I know I've got all the numbers in my stem plot. And now I can, make a comparison for the spring to the summer. I can see, once again, in the spring, typically classes in the 30s. That's the most prominent stem here, one of the most leaves. But in the summer, classes seem to be a little bit smaller, with typical class size being in the 20s, more classes in the 20s than anything else. I can also see in the spring, I tend to have much larger classes. Maybe I've got some classes in the 60s, whereas in the summer, my classes are not above 42 in the data set I have. Smaller class sizes are about the same, 14 and 18 in the summer, 17 and 18 in the spring. But I can quickly compare with this back-to-back stem plot. We'll move to another type of graph in our next video.